To their credit, grasshoppers are much more skilled than they might appear at leaping across yards and between trees. There are extremely minute details to take into account, such as the launch pad material's resistance. Are the grass blades springy? Determine the intended distance, speed, and landing as well as the plant's twigs' brittleness. The majority of leaping robots can't match the insect because their leaps can only begin on very rigid surfaces. However, a brand new bouncing robot created by scientists at Carnegie Mellon's College of Engineering is leapfrogging those barriers and offering tremendous hope for the future of automated devices. Researchers under the direction of mechanical engineering professor Sarah Berg-Breiter recently improved the latch devices that propel the robot upward. These latches were previously mainly viewed as straightforward on-off switches that allowed the discharge of stored energy. Berg-Breiter and her team, however, used mathematical modeling to show how these latches could both direct energy production and regulate the flow of energy between the jumper and the launch surface. The team placed a tiny robot that could jump on top of a tree branch to test their theory, and they captured the exact energy transfers during the initial stages of the robot's jumps. They could tell the device recovered at least some of the energy that was initially transferred to the branch just before liftoff by observing the branch recoil before the robot leapt. Berg-Breiter said, "We discovered that the latch can mediate energy transfer between the jumper and the environment that it is jumping from as well as energy production." Other cases using a different latch variety also showed an unconventional energy recovery, according to researchers. In those cases, the branch gave the bot a little shove after it jumped off its surface, regaining some of its momentum and allowing it to soar higher. Researchers can now start thinking about how to incorporate these interactions into upcoming robotic designs since they have a better understanding of the interactions that take place in the initial phases of jumping. Additionally, biologists can obtain a better understanding of how insects move through different terrains like grass or sand. Because they are released in mere milliseconds, controlling insect-sized robots has proven to be a challenging task, according to Berg-Breiter. Now that we have more control, we can make our robots leap up 1 foot or 3 feet. It's really amazing how the latch, which we already require in robots, can be used to control outputs that we previously couldn't control.